Learn how to prepare for a work at height procedure by reviewing documentation, understanding responsibilities, and covering each personal fall protection system component. Manual navigation activated.
Working at height procedures are fundamental guidelines to ensure the safety of workers performing tasks at elevated heights. These procedures are essential in any environment with fall hazards and must be strictly followed to prevent serious accidents. The procedures should clearly define the responsibilities of both workers and supervisors, specifying the required personal protective equipment, such as harnesses and lifelines, and the proper installation of collective fall protection systems, such as guardrails or safety nets. The Daily Task Risk Assessment, or TRA, is a key part of planning our work. The TRA helps us identify and evaluate any risk specific to the day's task, allowing us to take preventive measures to reduce the chances of falls or accidents. It's important that everyone involved reviews and understands the TRA before we begin work. During the task, it's vital to keep an eye on how well we're sticking to these safety measures. The foreman will be checking that all safety protocols are being followed and will watch for any new risks that might pop up because of changing conditions on site. If any safety measures aren't being followed or if new risks are spotted, we need to stop work immediately until we fix those issues. When conducting work at height where individuals are positioned within or above 2 meters of an unprotected edge, a permit to work, or PTW, authorization is mandatory. The permit to work system is a critical safety tool designed to ensure that all necessary precautions are taken before commencing high-risk tasks. Depending on the type of work, you may need a hot work permit or a cold work permit. A hot work permit is required for tasks that generate heat, sparks, or flames, such as welding, cutting, or grinding. In contrast, a cold work permit is used for tasks that do not produce heat or sparks, such as mechanical work, maintenance, or inspections. The PTW process involves a thorough assessment of the worksite to identify potential fall hazards and verify that appropriate safety measures are implemented. It requires detailed documentation of the safety controls that will be used, such as personal protective equipment and any temporary fall protection systems. Additionally, the permit ensures that all personnel involved are adequately trained and aware of the safety procedures relevant to their tasks. As the HSE supervisor, I support the HSE manager in implementing our work at height procedures. I conduct periodic inspections to ensure that access devices for work at height meet HSE requirements. I check compliance with work at height HSE rules and take immediate action if any deviations are detected. I report all problems and violations to the HSE manager and assist in disseminating and indoctrinating workers on safe work practices related to working at height.
As the site manager, my primary responsibility is to ensure that all work at height procedures are implemented effectively. I administer and make available all necessary resources to carry out these tasks safely and in accordance with our procedures. It's crucial that we analyze risks associated with work at height continuously and provide the resources needed to implement control measures. I also ensure that everyone on site is well informed about these procedures and that all personnel working at height are properly trained. Additionally, I communicate with all subcontractors to ensure they strictly adhere to our work procedures while on the project.
As the construction supervisor, I support the site manager in implementing our work at height procedures. I ensure that the necessary resources are available for activities under my responsibility and participate in preparing the risk analysis for these activities. Before starting any task, I make sure that all measures established in the risk analysis are in place. If I become aware of any deviations from the procedure, I take immediate action to correct them.
In my role as the site HSE manager, I support the site manager in administering and implementing the work at height procedures. I organize training sessions to indoctrinate all project staff on these procedures. My responsibilities also include monitoring the proper implementation of these procedures through inspections. I assist site management in developing risk analyses by suggesting the most appropriate control measures. Additionally, I analyze findings from inspections and take necessary actions to ensure compliance.
Personal Fall Protection Systems, or PFPS, are essential for ensuring the safety of workers performing tasks at height. These systems are designed to prevent falls and minimize the impact if they occur. The full-body harness is made of durable materials like nylon or polyester and is secured around a person's body. Its primary function is to evenly distribute the forces generated during a fall arrest across the legs, hips, chest, and shoulders, reducing the risk of injury. This harness system is designed to withstand fall arrest forces of up to 5,000 pounds. The harness features multiple connection points known as D-rings, typically located on the back, dorsal point, and the front, sternal point, allowing for versatile use in different work scenarios and anchorage systems. Some models also have hip connection points for tasks that require positioning at height. These D-rings must be strong enough to withstand a minimum force of 3,597 pounds. A critical component of the lifeline is the shock absorber system, which helps reduce the impact on a worker during a fall. This system can extend up to approximately 1 meter, absorbing the arrest force and ensuring safer fall protection. When using a full harness system with a shock absorber, it's essential to calculate the required clearance below the working surface to the nearest obstruction. This ensures that the system functions correctly in the event of a fall. The calculation involves summing the following parameters: lanyard length, LL, deceleration distance, DD, height of the harness dorsal D-ring, HH, safety distance, C. A self-retracting lifeline/lanyard is a device designed to arrest a fall by automatically locking a drum wound line when a fall occurs. During normal movement, the line can be slowly extracted or retracted with minimal tension. Self-retracting lifelines and lanyards that limit the free fall distance to 2 feet or less must be able to sustain a minimum static tensile load of 13.3 knots, 3,000 pounds, in all directions allowed by the fall arrest system. Those that do not limit the free fall distance to 2 feet, along with rip-stitch lanyards and deforming lanyards, must withstand a minimum tensile load of 22.2 knots, 5,000 pounds. Before use, every component of the fall protection system must be thoroughly inspected for signs of damage, such as worn connections, cracks, or other defects that could compromise safety. If any issues are found, they must be reported immediately to a supervisor or the HSE department to ensure proper corrective action is taken. Wearing a full-body harness correctly is essential for your safety while working at height. Start by picking up the harness by the dorsal D-ring, the large metal ring located on the back, and let the straps hang down to untangle. Once the harness is untangled, step into the leg straps, one leg at a time, ensuring they are not twisted and hang smoothly on both sides. Next, lift the shoulder straps over your shoulders, making sure they rest evenly without any twists. The D-ring should be positioned at the center of your back, between your shoulder blades. After putting on the shoulder straps, fasten the leg straps by connecting the buckles securely. Tighten the straps until they are snug, but not too tight. There should be enough room to fit a flat hand between the strap and your leg. Then, move on to the chest strap, fastening it just below your sternum and tightening it until it is snug. The chest strap should lie flat across your chest without any twists. Finally, adjust the shoulder straps by pulling the adjustment tabs downward. The straps should feel snug, but still allow comfortable movement. Ensure the D-ring remains centered between your shoulder blades, and all straps are evenly adjusted. Once everything is in place, attach the fall arrest system to the dorsal D-ring on your back, securing it to an appropriate anchor point. Before starting work, take a moment to walk around and ensure the harness is comfortable and secure, and if possible, have a coworker double-check everything to confirm that all straps and connections are properly adjusted. This will ensure that your harness is ready to provide maximum safety while working at height.